Okay, so let's go through some hand-in assignment questions. Number one, a person fires a bullet horizontally from a gun at the same instant that another bullet is dropped from the same height as the rifle barrel. Discuss which bullet will hit the ground first. Well, so it's one's dropping straight down, the other's going on an angle. This is really what's happening here, right? Like we said, they're accelerating the same in the y direction, so they're going to hit the ground at the same time. So for the key answer, I said the bullet fired horizontally has the initial velocity, or initial vertical velocity of 0, as does the bullet. So yeah. Number 2. Okay, so one day in the jungle of the Amazon, Professor Glick was stalking a very rare species of monkey, Projectilus avoidicus. He spotted one up a tree and decided to shoot it with a dart rifle. If the monkey begins to fall at the same instant that the dart leaves the barrel of the rifle, explain why the professor should aim directly at the monkey. You might have found this one tough. I drew a little monkey and a guy that's going to shoot it with a dart. Okay, so the way we can think about this, though, is if, let's say I had like a perfectly fast bullet that didn't drop at all, right? Well, in that case, it would make sense to point that thing directly at the monkey, right? There's no kind of arc in that. Because like pretty much that exact same moment that the monkey lets go of the branch, that bullet's going to be there, right? So that makes sense. But now let's say that we shot it a little bit slower. What's going to happen is it's going to go up, and then it's going to come down and maybe like be right about there. And you can think about these things, they are accelerating at the exact same rate. So if right when that bullet left the barrel of the gun, dart left the barrel of the gun, and started moving, that's when the monkey started moving as well. They're accelerating at the exact same rate. So that monkey would also be right here. Oh, he's a different color now too. It's a monkey. I'm not an artist, you can tell. Okay, so, but it wouldn't matter. This would be the situation every time because they're going to start accelerating downward at the exact same rate. Now, that one's kind of like a little bit tough to get your mind wrapped around, but it wouldn't actually matter how fast I even shot the dart. If I shot it even slower, it would just make a path that was more like this. But again, the monkey would be right there at that time. So you would always shoot it directly at the monkey. Okay. Now, a few of these ones. So number 3. Pretty much just like the ones we were doing in the main lesson here. So go through, see if you can figure out what we did here. And yeah, that's pretty much it. I'd go through and make the table. I know these don't have the table made, but I do that. I do it that way. Now, number 4, I'm going to go through just because it's a little bit different. It says a man standing at the edge of a cliff throws a stone horizontally at 4 meters per second. The stone lands 360 meters from the base of the cliff. How high was the cliff? Okay, so this case, we know the Vx is here. We know the distance. Now what we got to do is find the time. So it's kind of like we're going the other way. So this is x and this is y. I know I know Vx. It tells me dx as well. And I don't know time yet. And then if we did our chart, I got Vi, Vf, T, dy, and A. I know A is negative 9.81. I know my Vi in the y direction is 0, so I know that one. So in this case, what we got to do is kind of go the opposite direction. Before we kind of solved this side of it for t and then use that on the other side. This one, you guys are going to solve for t, going t is equal to d over v. And then that's going to be the same on that side. So now you're going to have 3 things that you know in the y, and then you just need to solve for dy. So that's kind of the way you'd work through that, and just make sure that you had the right formulas along the way. Number 5 is going to be a lot like the one we did in the practice problem. So a baseball is thrown at 30 degrees above the horizontal with a speed of that. How long does it take for the ball to reach its maximum height? So the first thing you got to do when you see these questions, though, is we need to split it up into its x and y components, right? We can't just use that 49 meters per second. We need it in the x direction and in the y direction. On the key, it says horizontal and vertical. Just, I've been saying x and y. It doesn't really matter what terminology you use. Okay, so once you do that, I would make my table if it was me. I'd go in the x and the y direction. And if you do that, you end up... I'm not going to do the whole thing here just for the sake of time, but for part A, what you need to do is know that at the very peak here, VF in the y direction is going to be equal to 0. That's kind of the key bit, or V2 it was saying here. So that's going to be equal to 0. So you get 0 minus your initial velocity of 24.5 divided by negative 9.81, and you get a time of 2.5 seconds. The total time... So part C, I'm kind of skipping ahead though, it's just 2 times that, right? You just go twice that speed. Part B, what did part B say? What was the maximum height? So dy. So in that case, we know VI or V1. We know that V2 or VF is going to be 0. We know acceleration is negative 9.81. And we can figure out D just by using this formula. Now the range, what you're going to have to do is, we know that the time is the same for the both, right? So we know that the time is going to be 5 seconds. Our velocity in the x direction, we figured out right off the bat. And we just need to solve for dh or dx, whatever you want to call it. And that's 212 meters. So number 6 is going to be similar to that one. I'm going to go on to 7 here. So it says an airplane is flying level at 80 meters above the ground with a speed of 350 kilometers an hour. The bombardier wishes to drop food and medical supplies to hit a target on the ground. At what horizontal distance from the target should the... I don't want to say bombardier or bombardier now that I quad. Release the supplies. Alright, so this is our situation. We got a plane that's flying above the ground and wants to know how far away should it release. So this question is really just the same as the ones that we've been doing where something just goes off the side of a cliff. It's going to be the exact same, right? So this thing's going to be going this way, and then you're going to let it go, but it's going to carry on in a parabola path. So making your little table on this side, we know that VI in the y direction is going to be 0. Acceleration is negative 9.81. We know that HY, which stands for height, or DY, is going to be equal to negative 80 because it's below us. And we just got to solve for time, which is 4.04. And we solve for that using this expression. And then once we know that we can use that on this side. And then just plug that into our equation and solve for dx. Okay, 8. I'm going to let you guys go ahead and do 8 on your own. It's similar to things we've done already. So for this one, it actually has given us the x and the y components of this thing already. We don't even really need our actual vector there. So we know Vx and we know Viy. It's like told us already. So we're good there. And then the other thing is this comes down like this, right? And the way that this was done is that we're going to say, okay, the initial velocity here in the y direction is going to be, so Viy was 210 meters per second. We're going to say that Vfy is going to be negative 210 meters per second. And that's what this is. It's because it has to be, right? the initial velocity in the y direction is the same as the final velocity in the y direction, just the opposite way. So that's going to be the same. You could have also solved it by calling this equal to 0 and then doing like the halves or the other method that we did. But this is one way of doing it. Okay, so then you can solve for t by just using this formula, which came from a is equal to vf minus vi over t, just rearranged. And then we solve for t is 42.9 seconds. And then the second part says how far down range will it hit. So we're looking for range or dx. So now that's going to be the horizontal component, which is just using this formula. V is equal to d over t. Yeah, and we know those things. So we know the time, we know our velocity in the horizontal direction. We just need to multiply them to find the distance in the horizontal direction. One thing that you might have missed though too was in the question it told you oh no, never mind, that was the last question. I was thinking one of them was in kilometers an hour, but it wasn't. Okay, never mind, carry on. Okay, so that's what you got from meters though, and then you can change it into kilometers. All right, number 10, you guys can go ahead and go through these ones too. If you didn't get a chance of doing this one, it's a good one. It's kind of like one of the ones we went over already, where it's going at an angle below the horizontal. You just need to make sure that you get your negatives right. That, like, if the velocity is going down, it's going to be negative. So just keep track of that. Your displacement is negative, and that's pretty much it. It's not that much more difficult than the other ones. Give those ones, or look through this if you gave those ones a try, and that one, and that's it. So that's it for that video, and I'll see you guys in the next one.